On this last equation, we were trying to figure out the equation of a line that's parallel to this line that passes through this given point. Okay, so what we did was we took parallel means that the slopes are going to be exactly the same. So we needed to kind of steal the slope from this equation. We didn't know what it was. It's not 3 until it's not 3 because you have to get the 2 out of there. So we manipulated the equation over here, figured out the slope was 3/2. And then we use that 3/2 and the 2 and the 1 to figure out our new y-intercept, and then we can figure out our new equation. Okay, so we're about to do the exact same situation. The only difference is the line is going to be perpendicular, not parallel. Okay, so you're going to see that the process is exactly the same feel, same everything. So if we're talking about perpendicular, we are talking about slopes again. Perpendicular means lines that are going to intersect at a 90-degree angle. Okay, so very, very specific. They cross each other very specifically. Not the fact that they cross, but they cross at a 90-degree angle. So in order to make that happen, it's all about the slopes. The slopes are going to be opposite reciprocals. Okay, what does that mean? Well, let's say, for example, you have a slope of 3/4 on some sort of an equation. Your perpendicular slope, that's the symbol used for perpendicular slope, would be the opposite reciprocal. So the opposite changes the sign. So if it's positive 3/4, this would be a negative, and then you flip it. That's what a reciprocal does. So -4/3. So if that's a slope or a given slope, this would be a perpendicular slope. So let me do one more. If your slope was, let's say, -3, and you wanted a perpendicular slope, first thing is you're going to change the sign. So instead of being negative, this one's going to be positive, and we need a fraction to flip it. So I put it kind of over 1, and then I flip that fraction. So it's going to be a positive 1/3. Okay, so a -3 opposite reciprocal is a positive 1/3. Okay, so that's kind of the idea behind it. So we need to take this equation, which is in standard form, because the x's and y's are on one side, no fractions, and we need to manipulate it until we know what the slope is. Once we know what the slope is, we're going to figure out what the perpendicular slope is, and then figure out our equation. Okay, so we need slope. It's pretty much how all of these start. We need the slope, and whether that is figuring out what the change in y or change in x is between 2 points, or taking a slope and using the parallel slope, which just means we use it as is, or a perpendicular slope, which means we're going to manipulate it. It's all the same kind of a initial start to every problem. So here's our equation that we got to steal the slope from. Okay, so here's our original equation that we have to steal the slope from. We're going to bump this x over. So we'd have a y equals, if we bump that 4x over, it becomes negative, and then -3. And that's it. So right now the slope is -4. Let's make it a fraction. So that equation slope is -4. We want the perpendicular slope, which is going to be a positive 1/4. Okay, we got everything we need. So we're going back to the beginning. This is the equation we're shooting for. So we're trying to find the equation of a line that's perpendicular to this. So there's our slope to it. That passes through this point. And then we're going to write this new equation in this form and in standard form. So we're going to have to kind of mess with this one to kind of make it look more in that form. That's our standard. Okay, so here's what we know so far. We know the slope is a positive 1/4 because that's the perpendicular slope. And then we plug in the point that we know. So that y value is -3, and then it's 1/4 times the x value, which is 0, plus our unknown y-intercept. Well, 0 times 1/4 is nothing, so that just goes away, and we are left with a b value of -3, which means we have everything we need. We have a slope of 1/4 and a y-intercept of -3. And so that is our regular equation. So let's verify it does everything that it's supposed to do. So this graph is supposed to do two things. It's supposed to pass through this point and be perpendicular to this equation, right? And I'm gonna look at that equation because that's kind of the graphing version of it. Be easier for me to graph. So let's graph that. So we have a y-intercept at -3. It goes up 1 over 4, up 1 over 1, 2, 3, 4. Up 1 over 1, 2, 3, 4. We go down 1, back 4, 1, 2, 3, 4. 1, 2, 3, 4. Okay, so that is our original line. And does it pass through 0, -3? Yes, it does. That's right there. All right, and then let's graph this one. Now it happens to have the same y-intercept. That is 100% a coincidence. That normally does not happen. That absolutely was a coincidence on this problem. Okay, usually they're different, but in this particular case, they're not. So we have the same y-intercept, and we're going to go down 4, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. And if we draw that line, we're kind of checking. So that is our original line. This is our new line. Do they actually look like they cross at a 90-degree angle? I would say they do. Okay, so that feels pretty good. The only last thing that we have to do is to put this thing into standard form, which, just to remind you, looks like this. So first thing we have to do is that the capitals refer to us not having any fractions. Well, we got fractions. So we're going to clear out fractions and then move the x over. Those are our two steps that we have to deal with here. So first thing is we're going to clear out fractions by multiplying every single piece by this denominator. So we're going to multiply a 4 times the y. We're going to multiply a 4 times the 1/4 x. And we're going to multiply the 3 by a 4. All right, should clear out our fractions. 4 times y is 4y. 1/4 of 4 is 4 divided by 4, which is 1 times 1 is 1x. So I'll just write it as an x minus 12. All right, and then last thing is let's bump the x over to the other side. If we do that, it becomes a -x plus a 4y, and that equals -12. And there is our standard form. Okay, so that is just a different version of that, but if you could graph both of them, they'd be the exact same lines. Okay, they just look different. All right, so that was talking about a perpendicular, and don't forget that a perpendicular is take whatever slope the original equation has and do the opposite reciprocal, and then everything else is exactly the same as all the other problems of creating equations.